GCSE physics boosters, distance time graphs. We're going to do velocity time graphs in another video. Don't get them muddled up. This one is about distance time graphs. Now, here's an experiment I do with my students. Put a long tape on the floor, long tape measure. Then somebody starts walking and somebody else starts a stopwatch, and every 5 seconds they say now, and the person walking drops something on the floor next to the tape measure. Then when they get to the end, you go along the tape measure and you write down all the distances and you put it in a table and you plot a graph. What does the graph look like? Well, if somebody's walking at a steady speed, then the graph will be a straight line. And looking at this graph here, you see I've drawn a line of best fit. It doesn't go through all of the points, but it's a lovely straight line. I've got about the same number above and below. And this person is walking at a steady speed, so the graph is a straight line. How can we work out their speed? Well, speed is distance over time. So from the straight line, the best point to use would be 50 meters in 30 seconds, and that would give you a speed of 1.67, 1.6 recurring, or just 1.7 meters per second. How would the graph have been different if they were walking faster or slower? Well, on the same axes, if they were walking faster, then in the same amount of time, they would cover a bigger distance. So basically, the graph would be steeper. So if they were faster, then the graph would be steeper. If they were going slower, then in the same time, they would cover less distance. So the graph would be less steep. So the steeper the graph is, the faster they're traveling. Okay. What would the graph have looked like if they were speeding up or slowing down? Well, look at this. Now, this is a very typical question you might get in the exam. Describe the motion of this object. Now, the thing to do is give plenty of detail and actually give numbers, give values in your answer. Okay, an answer that would get all the marks would be something like, okay, for 10 seconds, it travels at a constant speed of 3 meters per second, because after 10 seconds, it's a straight line before 10 seconds and they travel 30 meters. So that's 3 meters per second for 10 seconds. After 10 seconds, it begins to slow down. And how do I know? Because the gradient, the steepness, the slope is getting less. Now, its average speed over 30 seconds. In another video, we said average speed is just the distance traveled divided by time. So looking there, 50 divided by 30 is 1.7 meters per second. Now, what is its speed at t equals 15 seconds? So at that point in time, how fast is it traveling? And how do you find that? Well, okay, to find that, we need to find the gradient at that point on the graph. Okay, so what you need to do at that point on the graph, now I've done it a bit neater on the next slide, is we need to draw a tangent. So you draw a tangent, you do a nice big one as well, not a pathetic little titchy one. A tangent is a straight line which touches a curve at one point only. So you draw a tangent and then you get the gradient of the tangent, and that will tell you the speed at that point in time. So here we go. So what I've done at that point in time there, I've drawn my tangent, and then I've done a big triangle to get the gradient of the tangent, and it's going to be 53 minus 20 divided by 25, which is 1.32 meters per second. So remember, if an object is traveling at a constant speed, then the distance time graph is a straight line and the gradient is equal to the speed. If the speed of an object is changing, then the gradient will change. And if you want to know the speed at any instant in time, then you draw a tangent and you get the gradient of the tangent. And this is what the graph looks like if something is speeding up. Yes, the gradient is getting bigger. The gradient is increasing. To finish off, describe the motion of this object. And this object is Usain Bolt. Okay, so it's a distance time graph. And we notice that in the first 2 seconds, the gradient is getting bigger. So in the first 2 seconds, he's speeding up, he's accelerating. Then from 2 seconds to, looks about 9.7 seconds. From there to there, he's traveling at a constant speed because the gradient is a straight line. Should we work it out? Yeah, let's do it. So that's 9.7. Okay. This is 2. That's 10 meters. And that's 100 meters. Okay. So the gradient will be 100 minus 10. So it'll be 90 divided by 9.7 minus 2. So 90 divided by 7.7 equals, see how well prepared I am. So was it 90 divided by 7.7, 11.7 meters per second.